So again, int type, x is identifier, 0 is our initial value. Another way that you can write this exact same thing, and it means the exact same thing, is having a constructor initialization. So this is only introduced in C++. So this is called, the one before is C-like initialization because it's when we had used it in the C programming language. This constructor initialization is unique to C++. And so the way that you actually initialize it in this case is writing out int x, open close parentheses, 0. And again, this means the exact same thing. You can try it out for yourself on your own computer, and you will see that like nothing will happen, and that all of those integer x's mean the same thing. And there shouldn't be an error either. The only difference is that instead of having like an equal sign saying int x equals 0, these parentheses kind of act as those equal signs. So those kind of define what that value is going to be. And then the uniform initialization is the exact same thing as this one. It's just instead of using parentheses, you'll use curly braces. And so the reason why I'm even showing this to you in the first place is just because you get to choose which one you like. If you think that curly braces are fancier than parentheses, then go for it. If you think that you like equal signs rather than the other two, then go for it. There is no difference between what you use, but just remember one of them and then just to use it all the time. But they all mean the exact same thing. And so one of the example exercises that I have for you all to do, if you're like waiting for people to take notes, you don't have to do it, but it's just to create these same data types, but by using them in different ways. So use either constructor initialization, uniform initialization, or the C-like initialization that was in the previous slide. So creating the same kind of variable, but just in 3 different ways. And they all mean, again, the exact same thing. So you don't have to worry about like, oh, which one is better, or which one should I use? It's just whichever one you want to use. So any questions here? Okay, I think we're pretty good. So I'm going to move on and get to the actual type deduction. Okay, yeah, so this again, a lot goes into kind of the theory of C++. So you might be thinking like, we're still not really doing anything, we're still not like really creating anything. And the reason why we have to go through this, I guess I'll say it before we actually go over the slide itself, is because a lot about programming is creating an application and making it doing something, but also understanding kind of like the language behind it and understanding like the nitty-gritty details. And so that means understanding what the different types of declarations are, even though you might, or initializations are, even though you might only use one of those types. And understanding what all the fundamental data types are, even if you always like double instead of integer and whatnot. So in this case, this is another one of those like theory conceptual things, where we like basically describe that whenever we have a new variable and it's initialized, we can figure out what the type of variable is automatically by that initializer. And so this is something that's very unique to C++ called type deduction, where you can use like functions like auto and DCL type, I'll just like say decal type, but this basically means that you'll take in the type of whatever was before you. Why you might want to use this is because, again, if you're using a bunch of integer types and you don't want to keep on writing out integer, or for some reason these variables are like intricately linked to one another, so they basically are together or they basically mean the same thing, then you might want to use like auto to like set foo equal to bar, and you want to have the exact same value and the exact same space and the exact same type as whatever you had before. So in this case, in your initializer, you can use auto as the type specifier for the variable. So you can try writing this out on your own Replit or MinGW compiler, and again, you should get the same like results. Like nothing will change, and nothing will happen either, because all we're doing is still just initializing variables and just creating these variables. And I'm showing you the different ways that you can do so. And this last point just refers to that variables that are not initialized can also make use of type deduction. So in this case, we didn't define or initialize what bar is. So compare this example to this example. Here we actually like wrote out auto bar equals foo. And if you remember from like the previous example, like bar is just our variable name. Foo is another variable name. And so declarations allow you to like set equal something to 0, like our initialization, and we're setting it to some sort of value basically. And so whenever we're using auto is just saying that you're going to have the exact same type as the type before you. While decal says You don't even need to actually like define any kind of type here. You don't have to create initialization for it. It will already just automatically take whatever type you have from before it. Let's go into like our actual operators. So this is where you guys can actually start making stuff, start making your computer do stuff. And so basically for the rest of today, I think we're just going to be like going over these 9 different types of operators, and you're going to create your own like mini programs implementing these operators in like different ways. So the very first operator is the assignment operator. You don't have to worry about taking notes on this because you literally just did this. Initialization, where I said you created a space and you put a value into the space, that was assignment. That was assigning it a value. So the assignment operator is the same exact thing as just initialization. Okay, that's exact same process. So all we're showing like here in this case, like just an important note, an important aside, is that your assignment operator also allows you to take the like value of another variable. So in this case, we said x equals to 5, right? Well, if I said x equals y, well, now x doesn't equal 5 anymore. It now equals whatever y is. So in this case, we didn't define what y is, but just remember that like equal sign kind of like takes precedence from top to bottom. So whatever is like closer to the end of your program is going to be executed first. And then it's also replaced. So the value starts getting actually lost. So it's not like it's stored somewhere in the computer's memory. Like memory actually throws it away. X no longer equals 5. X now forever equals y. And it never ever did even equal 5 in the first place. So we only ever assign values at that moment. So if it changes at a later moment, this y value, it will not affect the new value taken by x. The next operator is arithmetic operators. So this is where you guys can actually do some math, and you can actually do something for your program. So the 5 arithmetic operations are addition, subtraction, multiplication, division, and modulo. So you probably already know like these 4. This is again basic simple arithmetic, but and they like literally correspond to whatever math you guys know. So addition is addition. There's nothing like fancy here. There's nothing tricky here. But the last one, the modulo operator, is what's actually represented as like this percent sign, gives the remainder of a division of 2 values. So I don't know why my example's not showing. Oops. Okay, yeah. So here the example exercise is 11 modulo 3. So what we're doing is basically going to divide 11 by 3. Now, if you remember, or like if you know, like this isn't a simple division because you are going to have a remainder, right? Like 3 doesn't go into 11. And so, yeah, if you want, you can write this, but it's like super simple. Just know that arithmetic operators just refer to addition, subtraction, multiplication, division. I would say like the main thing you should write if you don't know it already is modulo and what modulo represents. So if you don't know remainders, then it's important that you do understand what remainders are. So in this example exercise, all we're saying is we're going to divide 11 by 3, right? Like 11 modulo 3. So 3 goes into 11 3 times, right? Because 3 times 3 equals 9. And so our remainder in this case, in this division, is 2. So the result of this operation, where we say x equals 11 modulo 3 is 2. So x would equal 2. So I'm going to show you an example, again, using Replit, and you guys can follow along yourself, or you can create like your own programs. But I'm going to get rid of this part here. And I'm going to say int x equals 11 modulo 3. Okay, the same exact thing I said before. And now instead of like printing out hello world, I'm going to print out x. Okay, so I want you guys to see my screen. When we run this, the answer is 2. So finally, you guys were able to actually do something. We were able to create an operation, a statement for our computer to do. And this is simple math. So anything you want to do. So you can do like int y equals 15 plus 20. Okay, so this is again addition. So if you're going to print out y, then you should get out 35. Exactly, see? And then you could say like also int z equals 25 times 6. So if I wanted to print out z, I can run it, and it'll give you the answer for that. So 25 times 6 apparently is 150. So you can do basically any operation you want, any of these like basic operations using these values you know. So remember, the asterisk sign counts as multiplication, backslash is division, percent sign, which is just shift 5, is your modulo, so that's where you get your remainders. Then the plus sign is addition, and the minus sign is subtraction. So I'm actually going to give you guys a problem. So what I want you to do right now as like a practice is I want you to create 3 variables. So declare and initialize them into any values that you like, or actually no, declare and initialize them and name them, and then name them however you like. So you get to decide like what's a valid identifier, what's a valid variable name. But then I want you to do like a series of operations. So I want you to multiply. So like let's say we have, multiply the first and second numbers, divide the first by the second number, and then do modulo of the third and second number. And I'm just going to also give you guys like a big hint. If your numbers aren't like easily divisible, if you know you're going to get decimal points, then use double. Let's try instead like float. Like if you were going to, for example, use like decimal numbers, you could do like 91.88 times 11.5. And now if you run it, then you should get, decimals. So, okay, like if your numbers aren't easily divisible, or if you are using decimals. So you can define the values of the numbers however you like. But if you are going to use not easily divisible numbers or decimal points, then you have to make sure that the type is double or float. Float and double basically mean the same thing. So I could change this to double and you should still get the same output. So yeah, I'll give you guys like until 30, so 6 minutes to come up with like your own programs using these operations. So I want you guys to like play around with it. Okay, great. So everyone's getting this so far, which is great, which is awesome. So let's go on to the next kind of operators that are available to us. So yeah, I'm gonna share my screen now. And don't worry, I know the break is coming up, so we'll just go over a couple more operators, and then we'll go into our break at 50. So again, we tried out these different arithmetic operators. Everyone did amazing on that. Compound operators are the exact same thing as the arithmetic operators that we did. The only difference is that if you notice here, we're actually like combining our expressions together. So if you look at this little table, this table is like actually really super helpful. Specifically here, you see that whenever we write out that y is equal to y plus x, we can combine this entire part over here because we're just going to be repeating that like y is being basically added to x and then putting back that value into y. You can just write it as plus equals. So again, this is a stylistic preference. This is the exact same thing as this. So no matter how you write it, it doesn't matter. If this is too confusing for you, you don't have to worry about writing this. Some people, like, it's shorthand basically. It lets them write more code in less amount of time. And so x equals x minus 5 is the same thing as x minus equals 5. And again, they just do the same operations. Compound assignments are the same as arithmetic operators. The only difference is that you're not spending as much like line space and then coding yourself because you're combining these operators together. And note that it can only work when you're using the same variables again and again. So here in this case, we're setting y equal to y plus x. So we're setting the value of y itself equal to adding itself to another value. So only when you're like calling back that variable can you actually use like these compound assignments, if that makes sense. So you can only use compound when you have like y twice. So yeah, again, stylistic preference. If you don't want to use it, you don't have to. It's just something to keep in mind. Now the increment and decrement operators, again, this is also a kind of another stylistic, just to reduce line space. So instead of you writing these compound operators here, like how you would say plus equals 1 or minus equals 1, or arithmetic operators like this, where we say x equals x plus 1, and sorry, this should be an equal sign here, and x equals x minus 1. Instead of writing out all of this, you could just write minus minus plus plus. And that just basically means you're increasing any value that you have by a value of 1. So if I write, for example, x equals 5, and I say x plus plus, and then I print out that value, then my x now becomes 6. That's all that means. And again, they all mean the exact same thing. All of these mean the same thing. So it doesn't matter which one you use. It's just a nice kind of like shorthand that you could have available for you if you wanted it to. Now, like a quick note, like this is going back to the conceptual like theory of programming, but in early like C compilers, which is like the language before C++, these 3 different operations did not have the same meaning because they would have produced like different code depending on which one was used. But nowadays, because of code optimization, which is basically a fancy terminology for like your compiler became smarter, that these 3 expressions actually produce the same executable code. So you don't have to worry about it. These all mean the same exact thing. It can be used both as a prefix and a suffix. So what I mean by this is, like if you see with this example, this counts as a prefix because you're adding the plus plus before the variable. This counts as a suffix because you're adding the plus plus after the variable. And it does have actually a slight importance that becomes like mega important when you create like even more complicated code. And so in the case that the increase operator is used as a prefix, that it's used before the x, the expression evaluates the final value of x once it is already increased. So this basically means in the case that x equals 3, and you said y equals to plus plus x would now contain 4, and y also contains 4. So in this case, we're saying even before you assign the value of x to y, first thing you have to do is increase 3 to 4. So you can kind of think of this as like PEMDAS, or like the order of operations if you think of math. So like, you remember whenever you have parentheses, you would always like do whatever inside the parentheses first. Whenever you have a prefix, so still like the P letters, you always put that prefix first. You do the operation for the prefix first before assigning the value of y. So example 2 shows the opposite case, where x is 3, and so y equals x plus plus. So again, we increased our value to now 4, but y still only contains 3. So because it's a suffix, we first assign y to the value of 3, and then we actually increment our operator. So this is a slight difference, but it's an important thing to note if you are going to be using it. But again, if this is too confusing, you do not have to use it. It's just a shorthand. But it's important to like be responsible with the shorthands that you're using, and that it has different meanings, like a prefix versus suffix for your computer. So I'm getting some questions, so I'll answer. Okay, so I would say that it is good for you to know these, but you don't have to actually implement it. So it's good to know what increment and decrement are, so that whenever somebody else uses it in their programs, you're not like thrown back by it. So you can understand like why they have like these operators in the first place. And like I said, if you take like actual C++ classes later on, and you have to take like tests, and you have to write out like the answers for all this. Like for example, I did certification for Java, so a lot of the time they focused on like practice examples like this, where they tried to be tricky, and they tried to see if you understood what's going on with the computer, that like a prefix is different than a suffix, and that these 2 codes will actually do two different things. So it's important to note, but you don't have to write down the notes for everything. Again, I am showing these slides at the end of the day, so don't worry if you can't write down everything, or if it doesn't make sense the first time around. You always have time to review it. But just for those like who want an extra clarification, the difference between a prefix and a suffix is just when you actually perform this operation. So a prefix, because it's before, you do the operation before you do anything else. While a suffix, since it's at the end, since it's after, you only do that operation of like increasing after you did the other operation. So in this first example, this is a prefix. So we're going to change the value of x to become 4. So instead of x equals 3, we're saying x equals 4. And then we set y equals the value of x. So then y now becomes 4. So the prefix happens before us setting the value of y. While example 2, what we're saying is that x contains 4. So again, we're still creating the operation, but the operation happens at the end. So even before we increment x to 4, we first set x equal to y. So y first equals x to make it contain 3, and then x gets incremented to become 4. So when you look at these 2 pieces of code, they're very simple. There's nothing complicated, but they have 2 different results. And that's just because you put plus plus in the beginning and plus plus at the end. So that's kind of like the power of computer science right there and the power of coding, which is why just like knowing these little differences can make a huge difference later on. But do you have to use this in your own code? No, it's not a requirement. It's just something that's good for you to know. So if somebody else uses it, or if you're looking at some other code and you're wondering why is this not working, you understanding these operations is very helpful. So does this make sense to everybody? I hope that was like a better explanation. Okay, cool. So one last operation and then we'll take our break. But so all this before we did was still just arithmetic. We're still only doing addition, subtraction, multiplication, the simple stuff. Now we're going to do relational and comparison operators. And so what these do is actually like relates the values to each other. And again, this is still just arithmetic, but instead we're seeing like whether or not the values are equal to one another. So here, again, the equal to operator means like, is this equal to each other? And this is like actually a question someone asked beforehand. They said like, does the exclamation mean anything? It doesn't mean anything for a valid identifier. Like when you're naming a variable, you should never use exclamation mark. But for operators, exclamation mark means not. So it always means the opposite. So exclamation equals basically means not equal to. And then you know all of these symbols basically. This is less than sign, this is the greater than sign. And then this, whenever you put an equal sign after less than or greater than, just means less than or equal to. So here I have some examples. 7 equals 5, 5 is greater than 4, and so we can go down the line. But what I want you to first notice is that the result of an operation is either true or false. So this is when we use like our Boolean values because we're using true or false. So before, like all the operations that we did like gave us a value, actually gave us a number. Now the operations are giving us an actual Boolean value of true or false. So for example, the very first example I'm just going to go over, we're saying that 7 equals 5. This is a statement, okay? And so we know that equals means it's equal to. So basically this statement in our code, like if we were to write this in a code, would mean that 7 equals 5. And obviously we know that's not true, okay? That's completely false. So if we were to run this onto our computer would output false, okay? That's the Boolean value that it's going to be using. On this case, 5 is greater than 4. We do know that 5 is greater than 4. And so our computer would output true. In this case, it's saying 3 does not equal 2. 3 does not equal 2. So again, that statement is true. And now these two is also kind of tricky, but it's important to like remember. So this is 6 is greater than or equal to 6. Because we have this equal to sign, this is true, right? Because 6 does equal 6. It might not be greater than each other because it's still the same number, but because we have this equal to sign, this is a true statement. And so our computer would output true. And this over here is 5 is less than 5. This statement would actually be false. And the reason why 5 less than 5 is false is because we don't have an equal to sign. It's the same number. The same number cannot be less than itself. And so an equal to sign must be here in order for this to be a true statement, but it's not, so this is a false statement. To review, the computer would print out false, true, 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 false, if we were to write this into a computer. Before we go on to break, I'll just kind of show you how you would do that if you were to write it in an actual computer. So you would say like bool statement, and you would say x or like 9 equals 10, right? And this is what your Boolean statement is equal to. And so we know as people that 9 does not equal 10. So if we output our statement to our computer and we run this, it should get us 0, which 0 basically just means false. But here, I'll write it like in a different way. We say bool statement. So this is us actually. Okay, statement 2. This is us defining it. Or you know what? This is an even better way of writing it. We can just write out of this. 9 equals 10. We run that. Yeah, again, we just get 0. But if we did 10 equals 10, we should get 1. Yeah, we get 1. So a note, whenever you have an output of 0, that equals false, and output of 1, that equals true. And this is because we're using the binary form of classification. So again, it goes back to the fact that computers read things in terms of zeros and ones. So 0 also means like off, it equals false. 1 is on, it equals true. And like if you think about it, it's because your computer runs on like these microprocessors, and then you have like these gates that turn on or off that lets like this signal flow of information. And if none of this makes sense, don't worry. But all we basically have to remember is that 0 equals false and 1 equals true. So whenever you try to like output a value like this, so if I wanted to output statement 9 equals 10, that's false, so we should get a 0 come out. And so yeah, you guys can try this out for yourselves.